recently was the discovery of a planet that may end up being the closest planet to us of any of them that aren't in our solar system proximity. Astronomers have spotted an extraterrestrial planet around Proxima Centauri, the Sun's nearest neighbor. Proxima B is a planet that is just slightly larger than Earth. It orbits in the star's habitable zone, which implies liquid water and maybe life might exist there. Despite its Earth-like characteristics, Proxima B is a strange alien world. NASA scientists have spent a significant amount of time researching this strange world to uncover all of its mysteries. What have they discovered about this amazing planet? Is there life on it? Join us as we look into NASA's findings on Proxima B, which will expose all of its mysteries. The discovery of another planet was announced less than 6 years ago. This planet, known as Proxima Centauri B, or just Proxima B, is classified as an exoplanet due to its position outside the solar system. Astronomers have discovered a huge and rising number of Earth-sized exoplanets circling distant stars in recent years. Some are in their stars' habitable zones where temperatures may enable liquid water to exist on their surfaces. However, astronomers were particularly delighted by Proxima Centauri B, since the Sun its circle is the nearest star to our solar barely for 2 light-years away. DM Englada Esquade and a team of astronomers from the Pale Red Dot Initiative discovered Proxima B. Its existence was verified using the ESO 36-meter telescope high-accuracy radial velocity planet searcher or HARP spectrograph using a process called Doppler spectroscopy or the radial velocity method. This approach involves monitoring the spectra of stars for evidence of wobble which occurs as a star moves closer and further away from Earth. This is created by the gravitational impact of planets orbiting the star, the extent of which is used to calculate the planet's masses. Astronomers derived a minimum mass estimate of 124 Earth masses and a maximum mass estimate of 26 Earth masses for Proxima B. The existence of Proxima B was verified once more in 2020 by the European Southern Observatory's Very Large Telescope VLT, and it's for rocky exoplanets and stable spectroscopic observations. ESPRESSO, the transit approach, was used to discover the majority of exoplanets identified to date. However, for a star like Proxima Centauri, a low mass and less luminous type or red dwarf star, the method proved ineffective. With a mass of 17 Earth masses, Proxima Centauri B is quite comparable in size to Earth in comparison to our Earth's year-long orbit around the Sun. It circles its star in just 11 days. That implies that Proxima Centauri B is far closer to its star than Earth is to the Sun. However, because the star is a red dwarf which is considerably smaller and colder than our Sun, its orbit falls within Proxima Centauri's habitable zone. Surprisingly, Proxima Centauri B receives almost the same amount of solar radiation from its star that Earth does from our Sun. This means that water may exist on the surface of Proxima Centauri B. It might be livable, but we don't yet know all the intricacies concerning extraterrestrial habitability. However, numerous elements influence the planet's habitability, including temperature, the makeup of the planet's atmosphere, the presence or absence of water, and solar radiation. Red dwarfs like Proxima Centauri are known to generate flares which complicate and fascinate the habitability of red dwarf exoplanets. Scientists sought to ascertain if this exoplanet may sustain life after astronomers confirmed its existence in 2016. Sure, it was in its star's habitable zone, but several studies immediately threw doubt on the possibility of extraterrestrial life. As a result, the question of whether life may exist on Proxima B has constantly split scientists. All of these studies, however, imply that this topic will remain unanswered until astronomers analyze Proxima B's atmosphere, preferably by watching it when it passes in front of or transits its host star. However, a team led by astrophysicists at the University of Chicago decided in recent NASA-supported research that this is an improbable option. Emily A. Gilbert, a graduate student in the Department of Astronomy and Astrophysics at the University of Chicago, conducted the paper that described their findings. She was accompanied by experts from the Adler Planetarium, the University of Maryland Center for Space Science and Technology, and the NASA Goddard Space Flight Center's Exoplanets and Stellar Astrophysics Physics Laboratory. Still, even if life does exist on Proxima, there remains a major obstacle that must be overcome. It's referred to as space weather. When you hear about the weather as an Earth inhabitant, you automatically think of the sun, clouds, rain, wind, and so on. If you're familiar with the weather on other planets or moons with atmospheres, you could think of that type of weather as well. However, none of this is connected to space weather. It's a type of weather that begins in stars, including our sun, and pervades the space around them. Ionizing radiation emitted by flares on the sun or other stars is what causes space weather. Any life forms in faraway worlds might be eliminated by radiation. This is especially true for red dwarf stars, which experience more frequent flares than our sun. According to scientists, red dwarf stars could be extremely unpredictable, and Proxima Centauri happens to be one. Radio waves were utilized by astronomers at the University of Sydney in Australia to identify and explore space weather. Near Proxima, at least 2 planets are known to circle our sun's closest neighbor. One is Proxima Centauri B, which has almost the same mass as Earth, while the other is Proxima Centauri C, which is roughly 7 times more massive. Proxima Centauri B also orbits within the habitable zone of its star, where temperatures may permit liquid water to exist on the planet's surface. If you're hoping to see these as a sign of life, you'll be disappointed. The discovery of flares on stars such as Proxima suggests a bleak future for life on the planets in this system, because it is so close to the star Proxima Centauri. Proxima Centauri B is vulnerable to powerful outbursts of ionizing radiation from its star. It is crucial to note that just because an exoplanet is in the habitable zone does not indicate it can be colonized. This is true of Proxima B. Proxima Centauri is a cold, compact red dwarf star, which means the habitable zone is quite close to the star. In fact, it is considerably closer to the star than Mercury is to our Sun. According to research, this puts the planets very sensitive to hazardous ionizing radiation, which might essentially sterilize the planet. Our Sun, however, emits hot clouds of ionized particles regularly during what is known as coronal mass ejections. However, because the Sun is much hotter than Proxima Centauri and other red dwarf stars, our habitable zone is far from the Sun's surface, implying that the Earth is a relatively long way from these events, and thus this radiation does not affect us as strongly. Furthermore, the Earth has a very strong planetary magnetic field that protects us from these powerful solar plasma blasts. Scientists may conclude from analyzing the space weather near Proxima Centauri that all red dwarf stars are not the best settings for life. However, other elements may be at work here for any specific planet, such as how far it is from the star, how powerful its magnetic field is if it has one, and so on. Some red dwarfs are presumably more active than others in comparison. As a result, drawing broad statements about red dwarf scenarios is challenging. When high-energy extreme ultraviolet light ionizes atmospheric molecules, knocking off electrons and generating a swathe of electrically charged particles, an active red dwarf star like Proxima Centauri tears away the atmosphere. Freshly generated electrons gather enough energy during this process to easily escape the planet's gravity and dash out of the atmosphere. As more negatively charged electrons leave the atmosphere, they generate a tremendous charge separation that draws positively charged ions out into space with them. Proxima Centauri's habitable zone contains bursts of severe ultraviolet radiation hundreds of times stronger than what Earth receives from the Sun. That radiation provides enough energy to tear away not just the lightest molecules, hydrogen, but also heavier elements like oxygen and nitrogen over time. According to the model, Proxima Centauri's intense radiation evaporates the Earth-like atmosphere 100 times quicker than what happens on Earth. the scientists looked at two more elements that worsen atmospheric loss. To better understand how the process might differ, they began by considering the temperature of the neutral atmosphere known as the thermosphere. They discovered that as the thermosphere warms due to increased solar radiation, atmospheric escape rises. In addition to investigating the likelihood of life, Proxima B scientists have attempted to establish what the Earth might look like as a planet if it orbited Proxima Centauri. They conducted a simulation to figure out what the situation will be like. We're back to the idea of livable zones. Proxima B's orbit is in the habitable zone, which corresponds to the distance from its host star where water may pool on the planet's surface. But that doesn't imply it's habitable. It does not consider, for example, whether water exists on the planet or if the atmosphere might exist in that orbit. Atmospheres are also necessary for life as we know it because they allow for climate management, the preservation of water-friendly surface pressure, protection from dangerous space weather, and the preservation of life's chemical building components. The computer model employed by the scientists used Earth's atmosphere, magnetic field, and gravity's proxy for Proxima B's. They also computed how much radiation Proxima Centauri emits on average using data from NASA's Chandra X-ray Observatory. Using this data, their model predicts how the exoplanet's atmosphere is affected by the host star's powerful radiation and periodic flares. Even with cutting-edge technology, reaching our nearest nearby star would take thousands of years. For the time being, visiting Proxima B is out of the question. Meanwhile, scientists will continue to examine the planet from afar. They'll be looking for signs of water and possibly alien life forms. Let us know what you think of life on Proxima B in the comments section below.